Okay, on page 38 of your table of contents, you are going to put transforming linear equations. And you will need this big blue piece of paper to take notes on. So we're going to take notes on this on page 38. Now remember, when you fold that piece of paper and glue it into your notebook, you need to determine what side you're going to glue it on. So like my fold of my paper, because I'm folding it like a book, matches the fold of my notebook. Right? So it's going to get glued on page 38 so that the fold of the blue paper matches the crease of my notebook. Equations. And I'm going to glue this in my notebook after I'm done writing in it because there isn't a whole lot of space up here on the podium. All right, transforming linear equations. So we're going to start out with this idea of family functions, right? So functions, fancy word for equations. And a function, right? Family functions are functions. Remember again, those are equations. Whose graphs share similarities. Right? Functions, family functions, are functions, equations whose graphs show or share similarities. So like linear functions are all part of the family of functions, right? They're all in the same family because they all make lines, linear equations. If they're quadratic equations, those are all in the same family because they all make a quadratic, which we'll learn about at the end of the year, right? So families share similarities. So our graphs all today are in the same family. They're all linear. And then there's this idea of the parent function. And the parent function in a family, so the parent function of linear is the most basic equation. It's the simplest. It's the least number of frills, right? It's in linear equations, it's just y equals x. Y equals x. So the slope in y equals x, this is the parent function, the slope is 1. Or, if we were going to graph it, 1 over 1, right? And the intercept is 0. So if I was going to put that y equals mx plus b, right, that'd be y equals 1x plus 0. Well, you don't need plus 0, and that 1 is kind of repetitive, so y equals x. So if I graphed this parent function, it starts at the intercept and goes up 1 over 1. It's positive. This is the parent function. It's the most basic linear equation. Everything we talk about today, we're going to base it off of this. This is the original. We're thinking, how did the original, the parent, how did it change? What happened? So we're going to talk transformations first. And a transformation in geometry, in algebra, transforming something means to change it. And since we're talking about linear equations, we're going to talk about a change from the parent function. Transformation means a change, right? Transformers. They change from one thing to another. So transformations, there are three types. The first type of change, of transformation, is called a translation. And a translation is a slide. When we slide something up or down. And in equations, the slide is a change in y-intercept. It's a change in the y-intercept. So here's my parent function, f of x. This is just function notation. Instead of y equals x, it's written in fx equals x. The slope of the parent function is 1 over 1, and the intercept is 0. So I start at 0, and I go up 1 over 1, and down 1, backward 1. There's my parent function. That's my original beginning function. I'm going to compare this equation to this equation. So let's look. What's my slope in f of x equals x plus 2? What's the slope? Well, there's a 1 in front of it, so it's 1 over 1. And what's my intercept? Plus 2. So that means I'm going to go up 2, and from there I'm going to go up 1 over 1. So I'm looking, what is the translation? What is the change from this graph, the parent function, to this graph? Well, the graph just slide up 2. Let's try this one. Y equals x minus 3. What's the slope in x minus 3? Well, 1 over 1. And my intercept is negative 3. So I'm going to go negative 3. So what's the change from the parent function to this function? What's the change from this parent function, y equals x, to y equals x minus 3? Well, this one went down 3. Now let's talk rotations. So we talked translations were slides. Rotations are turns. And the turn in a rotation, if a slide, right, if sliding it up and down was changing the intercept, the b, right, what do you think would turn a graph? What value turns a graph? Well, we changed our intercept, we changed our b, so this time let's try to change the m, the slope. So again, we're going to start at the parent function, f of x equals x. So the slope of the parent function is 1 over 1, and the intercept is 0. So there's my parent function. And we're going to compare this change in slope. I haven't changed my intercept, I just changed my slope. So now, instead of my slope being 1 over 1, now my slope is 2 over 1. And my intercept is 0. So I have 0. And I'm going to go up 2 and over 1, up 2 and over 1. I'm going to go down 2 and backward 1, down 2 and backward 1. So what happened from the parent function to this function? It got steeper. It turned more vertical, right? It turned, it's steeper. All right, let's try the next one. Oh, that's a typo. Get rid of that negative value. Y equals 1/2 x plus 1. So let's talk. 1/2 x plus 1. What is going to happen to this graph? 1/2 x. Well, let's take off the plus 1 too. 1/2 x. Y equals 1/2 x. So my slope is 1/2, and my intercept is still 0. So I'm going to start at 0, and I'm going to go up 1 over 2, up 1 over 2, down and backward, down and backward. So what's the change from the parent function to the 1/2 x? It's less steep, it's flatter, it's not as inclined. So we can make a rule over here, I guess. If your slope is greater than 1, right? So 2. Right, here's your slope of 1. Slope of 2, it's going to be steeper. If your slope is less than 1, it's going to be less steep. Right? So a slope of 10 is going to be really steep. Right? It's going to be almost like this. And a slope of 3 is going to be less than that. Right? So the bigger the number, the more steep it is. The smaller the number, less than 1, so 3/4 is bigger than 1/2. Right? But 1/2 is bigger than 1/10, right? Or steeper than 1/10. Last, what are we on? Reflection. Reflection is the fancy word for flip. How do you flip a graph? If your graph, your slope is 1 over 1, your intercept is 0, right? So here's your parent function. How would you flip this over? How would you make it go the other way? How would you make your parent function flip and go the other way? You'd change the slope positive, negative. So since this is a positive slope, right, positive 1 over 1, we're going to change it to a negative 1 over 1, meaning down 1 over 1, down 1 over 1, down 1 over 1. So can you tell me, can you predict what this is going to change, how this equation is different than this equation? Can you predict how the parent function is going to change, and it's going to change to this one? So if I look, I know that it's going to be translated up 1, and it's going to rotate 1/2. So is it going to be steeper or less steep? It's going to be less steep, because 1/2 is less than 1. So let's test it. I go 1 over 2, and my intercept is 1. So if I look, it translated up 1, and it rotated down. It's less steep. This would be an easier hill to run up than this one because it's not as steep. All right, so let's talk about how these are different from the parent function. So what happens from here to here? What are the changes from the parent function to this one? Well, I know that it's going to go down 7. And what else is going to happen? My slope is 4, which my slope of 4 is greater than 1, so it's going to get steeper. Let's go from this one to this one. What's the difference from here? Let's pretend this is the parent function. This is what they start out with. Say this is what they start with. What's the change from here to here? What's the difference from y equals 4x minus 7 to y equals negative 4x plus 3? What's the change? Well, it started at negative 7, and now it starts at negative 3. So what was the translation? It went up 10. Because I'm down here at negative 7, I have to go 1, 2, 3, 4, 5, 6, 7, and then I have to go up to 3, 1, 2, 3, meaning it went up 10 spaces from this one to this one. And what else happened? What other difference is there in the equations? Well, my slope is 4, but this one my slope is negative 4, so it flipped over the y-axis. It's reflected. All right, so let's talk this one to this one. What happened? From here to here, what happened? Well, this one was at plus 3, now it's at minus 3. So what was our translation? How many did it move up or down? It moved down 6. It used to be negative, now it's positive, so it flipped over the y-axis. Now it's positive again. And last change was it changed from 4, which is a really steep slope, to 1/4, which is less steep. All right, so your homework, you are going to be practicing just looking and describing the transformations. So a translation is a change in y, that's up and down. A rotation is a change in the slope, so you have to determine, does it get really steep or is it less steep? And the flip is the positive, negative of the slope. If it's positive, it goes up to the right, and if it's negative, it goes up to the left. So you're going to be describing them. You're not graphing, you're just describing the slopes or the intercepts, so the changes. You're describing the change. Sometimes you're describing the change from the parent function, which is y equals x. Sometimes they'll give you two equations and they'll say, what are the differences between these two? Like, how much did it change from the first one to the second one? What are the changes? All right, so now go back and glue this on page 38 of your notes.